Hello everyone, I am back today with another amazing video of Vissim. Today it's gonna be com interface and node results. I got a few questions about that and I thought it's interesting enough to maybe do a video of. So when you do node or any com coding, what you want to do is you always want to use the com help because you need to understand the structure where you can access what. So for example, node results cannot be accessed via a node because the node evaluation results are tied to movements. And the reason for that is when you use a node and you want to evaluate it and it will give you like these outputs. As you can see, it is not for one node, it is for one movement. Because when you have this, Vissim automatically places Q counters for each movement, and it does it by creating those Q counters where it sees where it sees a signal head, a stop line for a priority rule or a conflict. And if there is none of that, then it will use the Q counter, it will place the Q counter here at the edge of that node. But normally, if you have any like properly controlled intersection, it doesn't matter if your node is like that or like this, because the Q counter will start from here. So when you go to the com hub, for example, you go to node in the objects, then go to node, then you go to inode attributes, and here you cannot see any evaluation basically. But what you can see is movements. When you click on movements, you will need to find the movements, what kind of stuff you can access from movements. So what you want is you want to go back to objects. You might be able to actually see here in the reference by, yeah, also it's here, so eye movement, but you can just come here on the left, you find movement and movement attributes. And as you can see, those delays and stuff are in the movement attributes. But you can also search for VEC delay or vehicle delay, what you get. And you can also there find the eye movement attributes. And by finding eye movement, you can track down where eye movement comes from. Like eye movement referenced by, and then you will see nodes and edges. So this way you can basically, by clicking everywhere, whenever you see something that reminds you what you want, you can find how to do it. So the way we deal with it is we go back to eye movement attributes. You can see here these. And we need to start from there. So it's going to be a movement. So let's go to Visual Studio. This is where I write my Python. You need to import some of these in order to make like the CSV to work and those kind of things. So you can just copy paste this. And then what I do, since I have one node, I just put the node number into a variable. You not necessarily need to do this if you want just to put one whenever you reference that node. I set up my paths. So I want to save the Excel file in my working folder. And again here, the way how to find this is if you go to com hub, if you just put working, let's just put without no topics found. Let's just put it together, working folder, that you can find it. But you can just put like maybe working. So you need to look for it. But if you can't find anything, you just start from Vissim. So you go here to Vissim. and you just look for here if there is anything you can find. So Vissim attributes. So if you just look for Vissim, you can see here already it has a working folder, or it has window title, version number. So if you want to access one of these main attributes, you can get it. So that's why I found this working folder. So I can just use that. So I don't need to type in like, my whole path, like, C, blah, 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 blah. So this way it is a bit easier. And also I just thought I showed you, maybe you can use this. So that is model path. So Vissim at value working folder, because it is Vissim's attribute working folder. Then the model directory, I just assign that. So that is my model directory. I will just use this. So when basically I create the whole path. Let's say C slash whatever and results.csv. So you could just type everything in if you want. It is just a bit more sophisticated um, way to do it. You can this way, you can write multiple or shorten your code if you have like multiple files and stuff. Then we open the CSV file for writing. So basically all of these is just, I only use these to access the file and to just set everything up to just initialize. But your key code, if you want to just, get your results, then basically this is it. But we are getting there. So with open, and this is the syntax you need to follow, that what is the file I want to open. I want to open it for writing and just creating new lines. And the writer, and I just create a header here. So I will, in the first column, it will be node number, from link to link, queue length, and delay. These are the stuff I want to put in my spreadsheet. You can use this if you want. You can just copy the syntax and just use it for your project. Or you can, use this data in Python or in any other software the way you want. That's why if you want to write it in a file, you can. Then all movements. So this is where I want to get all of these movements. So let's look at simulation 26. That is the one I run lastly. So these are my movements. So like link 3 to link 2, link 3 to link 4, link 3 to link 8, and so on and so on and so on. And one is the node number. At this number is basically at the link position where the node crosses it. So like this, on this link 9, it's 14.5 where the node crosses it. So from here, if you measure, it's 14 and a half roughly. So that's the way it is, the movement. And this is a concatenated string or text, but we need to look at differently. So if we go back to here, just put movements. I go to iMovement attributes. So you can see these are the attributes you can get. So there is no ID here or anything. So what we do is I'm going to take from link and to link, because that too will define the movement. So that will be like from link, so 3 to link 2, from link 6 to link 5. So, and also I want to get all of these movements so I can loop through them. So I need to put into, I don't want to say something wrong, is tuple or list. I'm not an expert in Python. But I just basically extract all that movement, all of those, all that 10 or 9 or something. I don't know many of that. So I extract all of those into a little container, and I will loop through every single one of them. And to get all of those, I use get all here. So if I go back to eye movement, where is it? No. So eye movement collection, there is a get all objects. There is a container or collection. I always forget which one is which. Basically, one is, I think you can edit, and the other one is just basically a read. You read out everything, and the other one is where you have. So this is the collection, and this is the container. You can read about it. I keep forgetting. I don't think it's important. I just always click both, and then I will find what I want. So all movements is my little container where I keep all of these movements. This vissim.net.nodes.item by key node number. Here I just access the node because movements are within a node or tied to a node or relative to a node because the node has the movements. As we looked at before, because if you go back to node, you can see movements is node's property. I'm just bad with these names, property, object, whatever. So that's a node's property. So first we need to access a node. So we say vissim.net.nodes because node is within net and net is within vissim. And then I use item by key node number. So I basically with this, I just say that the first node, because node number is 1. So here I could just, instead of this, I could just put 1. Or I can also, from you can put this into a, you can just say, my node equal that. And then here, you would just put my node. So it works like that. And then within a node, you have movements and get all. So now I extract all movements into all movements. Then I just use a loop, a for loop. So for movements, it is just a variable name I picked. It can be movements, ta 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 ta. It can be anything. You just need to use the same ta 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 ta, ta here. Yeah. So for movements in all movements. So this means that in all movements where I keep all my movements, I will just call each one of them movement. Or I call it movement. Probably that would be more. But anyway, so as it loops through, it will always put the current one it is checking into movements. So movements will be that single one of them. I should call it movement, I think, because it is stupid to call movements when there is one thing in it. So for movement in all movements, and then I will have a from link, a to link, a delay, and a queue length. You can add any more or whatever you want here. You just go back to node attributes. Sorry, not node attributes. The movement attributes. So you can get any of these: direction, edges, from link, position, fuel consumption, LOS, vehicle delay anything, QLAN max, person delay, whatever you want. And you can extract it by using movement. So movement is a variable where I keep the current movement. And then at value and from link to link, back delay, QLAN. As you can see from link, I just put from link, then I put to link according to the names here. So like copy paste that. But when it comes to vehicle delay, when you click on it, you see sub attributes 1, 2, and 3. So the first is sim run, then time interval, then vehicle class. In a string, you need to tell this. So vehicle delay, and in brackets, I just say current, all. So current simulation run, current time period, and all vehicle types. But if you go to queue length, where is queue length? So queue length, sub-attribute 1 and 2, simulation run time interval. So for this one, you don't have vehicle type. So here you only put current. And then basically that's it. The next two rows are only here to order. I don't need that print actually. Here to just basically write that data into the file. And again, you see here write a right row as I had it before here, where I added the header. That now I just put in each row, append it basically to the CSV. In every new row will be appended, and the new row will contain the node number. Then in next column, the from link, as you can see, this from link, then to link, then QLAN, and delay. I use here the same variable name as here. So if I put delay W here, I need to put delay W here. So I save this, go back to Vissim. You go to action, event-based scripts. Here you add it. Script file you select here, you add it, and just add the name. You can put the run type manually, or at least that is the way I use it now. Because I just start running the model. Wait a bit. And now I have some node results, you can see. 27 is the latest simulation run. And I now go back to scripts. And you can just right click and execute. And by executing, there is the result CSV file. Let me open that and show you what's going on, and we can compare the results with Vissim. So if I pick a row, a movement, maybe from 6 to 2, link 6 to link 2, no, maybe a one where we have actually results. So maybe 3 to 8. Which one is 3 to 8? So from here to here, so a left turn from the south. No. So 3 to 8, node number is 1, from link 3 to link 8, queue length is 2.3, delay is 83, 82.9, 83, and QLAN is 2.3. So as you can see, you can access node results, but not via a node. You need to go to movements, and from movements you need to extract it. I hope you enjoyed this. I can do more of these. Just let me know in the comments what kind of videos you want to see or what kind of stuff you struggle with, and I will try to do something for those. Again, thanks for watching. If you want to support me, just consider liking and subscribing. And also, if you want to pledge some money to me, maybe a price of a coffee, you can go to my Patreon and do that. You can find it in the description for more information. Thanks again. See you in the next one.